Hello everyone, I am Sankarshan, entry number 2021EE30175 of group 15, and I am here to present to you my ELP101 project. And today the topic of my project is diode. Right. Diode is defined as a two-terminal electronic component that only conducts current only in one direction, so long as it is operated within a specific voltage limit. Otherwise, it breaks down. An ideal diode will have zero resistance in one direction and infinite resistance in the reverse direction. In circuit diagrams, a diode is represented by a triangle with a line across one vertex, as shown in the figure. In ideal condition, this diode behaves as a short circuit if it is forward biased, and as an open circuit if it is in reverse bias. There are many uses of diodes in electrical engineering, and in this presentation, we will focus mainly on uses of diodes in many complex circuits. The first complex circuit is half-wave rectifier. Half-wave rectifiers transform AC voltage to DC voltage. A half-wave rectifier uses only one diode for the transformation. A half-wave rectifier is defined as the type of rectifier that allows only one half cycle of the AC waveform to pass while blocking the other half cycle. During each positive half cycle of the sine AC wave, the diode is forward biased as the anode is positive with respect to the cathode, resulting in the current flowing through the diode. Since the DC load is resistive, the current flowing in the load resistor is therefore proportional to the voltage, and the voltage across the resistor will therefore be same as the supply voltage. Vs that is the DC voltage across the load is sinusoidal for the first half cycle. So V out is equal to Vs. During each negative half cycle of the AC sinusoidal input, the diode is reverse biased as the anode is negative with respect to the cathode. Therefore, no current flows through the diode. Since no current flows through the diode, the output voltage will be equal to 0. Hence, combining the two cases, we get the following output. As we can see, there is no voltage in this half while we have a normal sinusoidal voltage in this half. So again, we by comparing the input supply and the output supply, we see that we remove the negative half cycle of the input supply while the positive half cycle remains as it is. Half-wave rectifiers are used in many areas, like they're used for signal demodulation purposes, rectification application, and for signal peak applications. There are many disadvantages as well. First is power loss, as one half cycle is lost to us, low voltage output, and constant output contains ripples. Now the second complex circuit is full wave rectifier. A full wave bridge rectifier is a rectifier that will use 4 diodes in a bridge formation. A full wave rectifier consists of 4 diodes and a load. This is the circuit diagram of a full wave rectifier. As you can see, it contains 4 diodes and one load. Here in this case it is a resistor. In the positive cycle, the diode A and C are forward biased and B and D are reverse biased. In the negative cycle, diode B and D will be forward biased and diodes A and C will be reverse biased. The following diagram show the flow of current in the positive half cycle and the negative half cycle respectively. Now we compare the input voltage and the respective cases where A and C are forward biased, B and D are forward biased, and by combining the two cases we get the total output current, and we see that only the negative half cycle is reversed while the positive half cycle remains as it is. Hence we get the following output current. Full wave rectifiers are used in many areas, like they are used in mobile phones, laptops, chargers, power UPS, our home inverters, LCDs, LED TVs, etc. Now the third complex circuit is voltage spike suppression. In case of an inductor load, sudden removal of supply source produces a high voltage due to its stored magnetic energy. These unexpected spikes in the voltage can cause considerable damage to the rest of the circuit. Hence, a diode is connected across the inductor or inductive loads to limit the large voltage spikes. These diodes are also called by different names in different circuits, like a snubber diode, flyback diode, suppression diode, freewheeling diode, and so on. When the switch is suddenly opened, the voltage spike is created in the inductor. Therefore, the freewheeling diode makes a safe path for the flow of current to discharge while the voltage offered by the spike. We can see that in the diagram, the diode is connected across the inductive load. Now, the fourth complex circuit is diodes and reverse polarity protection. The reverse polarity or current protection is necessary to avoid the damage that occurs due to connecting the battery in the wrong way or reversing the polarities of the DC supply to the circuit. This accidental connection of supply causes the flow of large amount of current throughout the circuit components, which might result in the failure or in worst case their explosion. Therefore, a protective or blocking diode is connected in series with the positive side of the input to avoid the reverse connection problem. As we can see in the diagram, a blocking diode is attached to the AC supply, to the DC supply, and this is the load. In case of the correct polarity connection, diode gets forward biased and load current flows through it. But in case of wrong connection, the diode is reverse biased and does not allow any current to flow through it, hence the load is protected. Now, fifth is diode and voltage multiplier circuits. Voltage multiplier consists of two or more diode rectifier circuits, which are cascaded to produce a DC output voltage equal to the multiple of the applied input voltage. These multiplier circuits are of different types like voltage doubler, tripler, quadrupler, etc. as per our needs. By the usage of diodes in combination with capacitors, we get the odd or even multiple of input peak voltage at the output. As we can see in the diagram, the diodes are placed in a cascading arrangement with a capacitor input supply. During the positive half cycle of the AC input, diode D1 is forward biased and diode D2 is reverse biased. So the capacitor C1 charges up to a peak voltage Vm of the input supply, the diode D1. During the negative half cycle of the AC, D1 is reverse biased while D2 is forward biased. So capacitor C2 starts charging through D2 and C1. Therefore, the total voltage across C2 will be equal to 2 times Vm. During the next positive half cycle, the diode D2 is reverse biased, so the capacitor C2 will discharge through the load. Likewise, by cascading the rectifier circuits, we can get multiple values of input voltage at the output according to our need. So now I conclude my presentation. These were some uses of diodes in complex devices. As you can see, diode is an extremely crucial component of electrical engineering, without which this world will almost stop working, as it is used everywhere from mobile phones to laptops to chargers, etc. Thank you.